morning, everyone. Today we'll be talking about stop throwing harder at the problem. It's normally the way like Monday harder. We will be talking about caching here. My name is Marcelo Altman. I work as a senior software engineer at Rediset. I previously worked a few years at Persona, doing a lot of things. Last 4 years, I was maintainer of Extra Backup, Persona Extra Backup. I'm a long time MySQL contributor. I'm an Oracle base. Something I'm really proud, and normally this is something that people are, wow, I'm a MySQL code contributor, but like on this audience, I think half of the people are as well. So just mad. And also like Redset is written in Rust. Since I started working in Redset, I also started contributing to the MySQL Rust driver.
I'm Gautam. I'm the CEO at Rediset. My past is sort of a lot of systemsy kind of stuff at Microsoft, Data Robot, at a startup called Store Simple, Cisco, Sun Microsystems back in the day.
So our agenda for today, we will be talking about scaling solution for an example query from the employees database. We will see how Rediset compares. We will do a demo and we will create it works. We will talk about integrations we have with proxy, and we will cover some case studies as well. So database scaling, to begin with, like when we have to scale a database, it means that our database is struggling and it's running out of resources. It can be like CPU, memory, disk, something it's struggling to serve queries. When we talk about database performance and application performance, database it's often responsible for like the majority of the latency and throughput from our application. So database has to be performing well in order for our application to be also performing well. We'll be talking about caching here, and cache is something that will never replace your database. It will complement, it will help your database scale. And caching, it's a solution for applications that require low latency and high throughput in terms of queries. On this presentation, we will be looking into a query from the employees database where we get all the active employers database and we count in which department they belong. This particular query here is with the standard employee database, no optimizations. And it takes mostly like half a second, like 37 milliseconds to run. So the first thing we'll have to do how to scale this particular query is to check how MySQL is executing this query. So we can see here from the explain analyze that we are doing a full table scan on the department employees database. We are then applying a filter to get only the to date where the date is 999 or 101, which means like it's an active employee. After that, for each row that we get, we'll have to do a lookup on the department, getting like the primary key. We will be doing that on a nested loop. We will aggregate all this data into a temporary table, and then we'll scan the temporary table in order to give the results back. So here, the first thing we can do to scale is very simple, like we are doing a full table scan. We can add indexes in order to optimize this query. So we can add an index on the filter and on the join column. So in this case, we will be doing like a covering index, which is the best solution we have. So if we look now, MySQL has chosen to switch like how it's doing the query. So right now it's scanning the department for like 9 rows. And then for each one of those 9 rows, it can do also a covering index lookup on the department employees, filtering the date and getting which one of the employees. It still has to go and aggregate the data into a temporary table. It's faster and scan the temporary table. And in this example, like just by adding the index, we cut the execution time from half a second to 152 milliseconds. So yeah, we didn't have to throw any hardware at the problem. We could scale just by adding index in the table. So the next thing we can do, we can check like configurations and like MySQL INDB, the biggest configuration is the INDB buffer pool. So we can ensure that we have sized our buffer pool enough so we are serving all this data always from memory. And we can check this by using like show global status, checking the INDB buffer pool reads to ensure that it's steady between executions. Like here we can see that INDB buffer pool reads did not increase between the executions. So this query was executed 100% from the buffer pool. So we are running in 138 milliseconds, which is 20 milliseconds faster than it was before. So in terms of optimizing this query, we can go and create like aggregate tables to have the result pre-computed and everything, but that's not always the case. So in a sense that we as DBAs, what we can do in order to optimize this query, it's what we have here. So having a look of what MySQL is doing under the hood to optimize, to run this query in the most optimal way, we can see that like how % of the time here it's being wasted or used reading the data from the buffer pool pages. And here is the first point I want to make, is that even though MySQL has a cache, which is the INDB buffer pool, we are caching raw pages. Like we still have to go and extract the rows from those pages every time. And a database is way more complex. It has to do way other things. Like in here, we can see part of the time it's being used in row search and VCC. Like we have to ensure that we are serving a consistent snapshot of this of those rows. So your database has to do way more things than just read the actual pages. The other point I want to make, which is like those two functions here, we are doing a read on the temp table and we are doing an update on the temp table. And my point here is that for every time we are executing this query, we are having to aggregate, like every aggregation, every function that you do on your query, it has to be done over and over again. So it will take time in order to serve these 9 rows every time you execute. The idea here is that we want to see how much I can scale this, how much I can run this query in a particular hardware before I have to scale. So here we will be looking into how long it uses a CPU time, because a total time execution here account for other things like sending data on the socket, on the TCP. And if you put enough like concurrency, what will be mattering here is the CPU time. So for this particular query, we are executing in 136.34 milliseconds. This test has been done in a CPU that had like 16 cores with C6A for X large in AWS. So to get the potential queries per second I can do this query on a 16 core machines, I have to get like the 16 cores, divide that by the amount of seconds it takes, and I will get a potential query per second of 117 queries per second that on a 16 CPU machines I can execute this particular query. So ReadySet, how ReadySet compares? ReadySet is a result of a decade of research of a PhD thesis from the MIT Institute named Partial State and Data Flow Based Materialized Views. We have our code in GitHub, like you can go, you can all people compile, you can submit pull requests, you can submit issues, we accept contributions. Basically, we have like 3 products. We have core, which is like ReadySet that you go, you install on your machine, you deploy, you manage. Or we also have like a cloud version, which is a beautiful UI. In a few clicks, you can deploy ReadySet for you. I will not go into a lot of details about how ReadySet works. I gave a talk last year about ReadySet. Here is the link on YouTube if you want to see everything. but I would like to bring like two highlights. The first one is that we implement the wire protocol from MySQL and Postgres, meaning that if you talk about caching with Memcache, Redis, Bulky, you have to implement a different API on your application in order to be cache aware. With Redis you have to do no code changes. You just have to change a URL string to point to Redis. The same way you do a query on MySQL, you will be doing queries on Redis. If it's something that it's not cached, it will proxy it back to your upstream. If you are using like proxy, like ProxySQL, it automatically integrates with ProxySQL. You can redirect just the queries that you want. And one other highlight is that different from other cachings where you have to either invalidate your cache or you have to put a TTL that will like guarantee that if something changes on your data during the time of the TTL you are serving, stay read. We have incremental view maintenance. We subscribe to MySQL. We listen to binary log events. And if something changes on your database that will adjust, like it will impact anything that is cached, we will automatically update the cache for you. So there is no cache miss. There is no invalidation. Once something is on cache, it's always on cache and it's always up to date.
Can you run off minimal RBR? I'm assuming you can.
Say that
Can
again.
you run off minimal RBR for cache invalidation?
I can really.
Minimal RBR.
Row-based robot, minimal row-based robot.
Not at the moment. We have something that is halfway done with.
Obviously, for us to test that, but if you can't run minimal RBR.
It's something I have that halfway cooked already, so we just got other priorities and I left that. But we can talk.
Interesting to know that.
Exactly the same query. If we execute that on Redis app, it takes 0 milliseconds, so it's sub-millisecond. And here, there is one feature request I have open. I think Daniel, I don't know if he's here, like he started with it. There he is. For MySQL client to report the last millisecond, because for us, this is important. Like 9 milliseconds, it's a lot. And here we can see that we are running in sub-millisecond rates. Executing exactly the same perf to see how much time we spend on CPU for this particular query. Here we are executing the same query in 650 microseconds, like it's sub-milliseconds latency. Executing the same calculation on the 16-core CPU machines, Redis can deliver 24,000 queries per second. So if we look into the improvement, this is a 209x. And like our t-shirt is wrong, it's not 100% X, we need new t-shirts. So. Right, like, but this is just like you are still running on the same hardware, it's faster, yes, but can we scale down our infrastructure if we are using Redis app? So to prove this point, I got the lowest machine on the same CPU family, which is 2 virtual CPUs. And while the other one costs 61 cents per hour, this one will cost only 7 cents per hour. The latency doesn't change, like it's still the same CPU clock. But with 2 CPU machines, Redis can still deliver 3,000 queries per second. While MySQL was doing 170. So it's still like we are 26x with a way lower hardware than MySQL. If we think about costs, this particular machine costs $5,000 per year on EC2, while Redis it's gonna be like only 670. If we talk about summary of all those improvements, like Redis is 8 times cheaper than MySQL on that particular machine. It still delivers 26x queries per second, like you have a way higher throughput, and you still, every single execution of the query, it's still like 209 x improvement in latency.
The limitation is basically memory, your caching in memory there.
It's memory, it's
You don't need any size, and you can probably adjust that according to what usage requires, basically.
Yeah, the rule, the more the better. We have like LRU, like semi buffer pool, so the more you have, less cache misses you will have. Yep.
You benchmarked yourself against using Memcache?
No, benchmark is something that we are starting to invest with to see how we compare with other machines. But normally, if you have memcache, you already rewrote your whole application to be memcache aware. So it's really hard for people that have converted all their application to use a different API to convert back to something that will deliver basically the same thing.
But the performance will be the same. I mean, it'll be a memory performance, so therefore it's likely to be the same all the time.
The reason we don't use memcache anymore is because we benchmarked MySQL versus memcache. This is MySQL protocol, by the way. I know you can address MySQL with memcache protocol if you could anyway. But we found that on a memory resident data set, point select on primary, MySQL was essentially the same speed as memcache.
Right.
So we just use MySQL.
I think the main difference here is you're doing complicated, you're doing complex joins.
Yes,
And that's where
not just point select.
that makes a big difference.
Yep.
You can't-
Just wondering about the discussion because I feel like it's apples and oranges because Redis will adapt, change it in the data, whereas Memcache is static.
Yeah.
It's inherently very different.
And in that case, like we should
I'm
be
making speed comparison there.
we should be comparing like MySQL and Redis set like in the point selects.
Yeah.
I will move on, or we will be running out of time. Redis set demo. So this is the part that normally everything fails. So here I have like a MySQL and Redis set running on my local machine. I have a Rust application that will be executing the same query in a loop. And I have a second background process that is updating the data set, like randomly changing users from one department to another. And we will see how it looks. So right now we are executing this query in MySQL. It's executing the latency. Do I have an overview there? Okay, now it's better. We are executing this query in MySQL. We are having like a 80 millisecond latency, and it's doing roughly like 12 queries per second. And we can see things are changing. I'm gonna click here and it will change to Redis set. And we can see that the throughput has gone higher. Latency now it's on sub-millisecond. This is executing in 30 microseconds. And while I was developing this application, I saw that like we have queries per second here that's doing roughly 15,000 queries per second. And my math was not matching. Like there's something wrong here that if something is taking like 30 milliseconds, I should be doing like 30,000 queries per second. And I realized that we take more time displaying the output than querying the database. So I implement a refresh rate. So if we change refresh rate here, like to something to print only every 10 interactions, we actually get like the 33,000 queries per second that I was expecting. So yeah, I hope this will convince you at least to give a try for Redis set.
So, how many updates per second were you doing on that? I mean,
As much as it can. So I have a loop that it's updating, but it's updating on a primary key. Where it's on a primary key.
Go ahead,
Can the same multi-threaded?
Not yet, but multi-threaded should still valid. And that's a good point. This is on a single thread, like it's 33,000 queries per second on that single thread.
so, if you had, I've got kind of a specific example on here.
Okay.
Is there, what would be the latency if you're using it for pull through? So you cache only certain queries, and we're just redirecting everything back through. You have another hop then.
Yeah, so there is a bump in the wire overhead for proxy certain queries. We have measured it to be about 10% overhead approximately. So if Redis wasn't in the picture and the client was sending a message directly versus Redis being in the picture as about 10% overhead essentially for querying.
And it's the same as like in every proxy. Like you have to open the package, understand that this is an insert, it's a select. In our case, like you have to parse everything to see if you have a cache that will match that digest, and then you decide if you proxy or you insert.
Cool. I'm just going to elevate the talk a little bit more and talk a little bit more of the philosophical aspects of the way to think about this particular problem. The key sort of idea that I would love to plant in everybody's mind out here is that generalized solutions, which is essentially MySQL and Postgres, I mean, these are generalized solutions. They are expected to work for all situations, all scenarios, including edge cases for the entire gamut of like the SQL query language. And that's a generalized solution, and that's what it's supposed to do. But there is a burden associated with writing a generalized solution and running a generalized solution. And that cost of generalization essentially shows up in each and every query execution. When a particular query is being executed by the system, the overhead essentially shows up in like all of the things that we saw in the flame graph. Essentially, there were parts of like MVCC code that was getting executed all over the place when honestly, it's the exact same query running again and again and again, and should not have had to go through all of those kind of code paths. So the big point out here is like the cost of generalization is really, really high. But that's what we go to MySQL and ProxySQL for, and Postgres for. And the way that a lot of people try to scale the solution out is by just adding more units of this exact same thing. And the units that we're talking about out here do not get simpler. They are the exact same complicated logic that does the complicated parsing, that does the complicated result collection and execution, but in more and more pieces of hardware. And as a result, the cost just completely keeps going up without any kind of a real benefit to this whole thing. And so the thing that I would love for people to understand is, in reality, even though Postgres and MySQL have been written for this kind of a broad generalized situation, when you're actually running it in production, the number of code paths that are being touched inside Postgres and MySQL are very, very small. It's a very small subset of that code path. And ideally, what you would have loved to have is some sort of a hybrid solution where you have some sort of a cache that automatically keeps maintaining results for well-known queries that are adding load. And for everything else, that's the broad, edge cases, there is still MySQL and Postgres that you can always rely on. I keep mentioning ProxySQL because I'm going to talk a little bit about our integration with ProxySQL after this. And so, in like the recent few months, a few cases where this has sort of taken effect and is front of mind for a lot of people is even last week, DeepSeek versus the big LLMs, they've had a big tussle around this whole thing. And essentially, if you look at it, it's a very similar kind of problem that they've come across. Big LLMs take the entire data on the internet and try to make it so that anybody can ask questions against that entire big data set. And so it's processing the entire data set. But what DeepSeek did is it said, hey, we're not trying to assimilate all of the data. We're just trying to emulate what another LLM does. And that too only for a smaller subset of questions that people might ask, some realistic questions. So what they've done is they have converted it from a generalized solution to a more common scenario solution. The common scenario is that people will have maybe, 10,000 or 100,000 sort of set of questions that they will generally ask out of an entire data set. And if you can train a smaller model that does this entire thing, the cost is essentially orders of magnitude cheaper than running the big LLM kind of solution. It is much faster, much cheaper to train to run this. It's the exact same argument that's being made by DuckDB folks as well. We are huge fans. And DuckDB has said, hey, we've seen big data, we've seen these massive distributed systems that are doing, number crunching and data crunching. But is everybody's data size really that big? And, there's tons of surveys that they carried out. I don't know, tens of percent, 60, 70% of people really are not dealing with big data. They're dealing with much smaller data. And you don't really need massive amounts of, hardware to actually solve these problems. Just thinking about where data is being spent, where the CPU is being spent, actually solve the problem for you. And so that's something just for you to think about a little bit more. In terms of how ReadySet sort of really capitalizes on this whole thing, there are two big observations that we make. One is that in general, in production, this is obviously not true in all cases, but in general, for web application workloads, most of the queries follow a zip field distribution, which means that imagine that you have, say, 20 queries that are running against your backend database. You will find the top 3 or 4 queries dominate the amount of load that is there inside your system. And it is, if you are able to cache just these 3 or 4 queries, you've actually brought down the CPU utilization and the load on your system by 60 to 70%. In some cases, 80, 90%. But the way that today people solve this problem is, let's throw another chunk of hardware, another chunk of hardware, another chunk of hardware, and very soon, in order to scale by 10x, you've thrown 10x the amount of hardware out here. But instead, just one single caching solution, which just caches the first 4 queries, and suddenly you drop down the amount of load on your backend database by huge amount.
So do you provide HA ready set?
Yes. Ready set is by default deployed in HA configuration. There is essentially load balance of two separate instances.
So there's no instances, in theory, there's no worry about the specifics.
That's correct, yeah. Cool, anyway, so this is sort of really the small little point that I would love for people to think about and mull over really hard. This is where money gets spent. This is, managing 10 systems requires a lot more resources, a lot more money, a lot more time when something fails. And so smaller is better, fewer resources is always better. And that's the thing that, we should all be moving towards. So I want to spend a few minutes talking about our integration with ProxySQL. ReadySet can be deployed in multiple configurations. One configuration that we have found a lot of people using is with ProxySQL. Essentially, the way that ReadySet, I've seen a lot of people use ReadySet is, here's an application which talks to a query routing layer. The query routing layer is aware of the primary database and it's aware of a read replica. And so ReadySet can be deployed as a read replica. And all that you would do is you would configure the query routing to a layer to say, here is another read replica that you should go ahead and read certain queries from. Because these are the cache queries. These queries you can actually forward to ReadySet. And the query routing layer of choice for a large number of our customers is ProxySQL. And so we actually have taken that really seriously. And we are, as everybody's aware, ProxySQL is a really beautiful piece of code which does MySQL proxying. It does a lot of really fancy features, and which is exactly why a lot of customers are actually using it. But one thing that we've done is we've embraced ProxySQL through ReadySet, and there are 2 big contributions that we've made. Marcelo touched upon it. On the open source side, we actually have written a small plugin inside ProxySQL, which automatically will detect. It'll take a look at all of the queries that are going through. It'll find out which are the queries that are contributing the maximum amount of load to the backend database, and will start offloading those queries quite automatically by sending it to ReadySet. So essentially, it'll send a request to ReadySet to say, cache this query. Once ReadySet has cached this query and it's received an ACK out here, the query routing layer will add, the plugin will add a policy that says, now onwards, when this query is actually encountered, automatically send all of those queries to ReadySet. And now you will start seeing those sub-millisecond latencies for all those queries that are getting routed to ReadySet. And now the next thing I just want to announce is that we are also embracing ProxySQL in the cloud. And we're doing the exact same thing, wherein a lot of customers need this kind of a really efficient proxy routing layer, and we've added support inside the cloud as well.
We have 2 minutes. Can we take that offline?
Cool. There are a couple of case studies. I'm not going to go into details out here, but this is all you can take a look at it at our blog, but it's fantastic stuff. And this is real numbers. There's this company which was using 8 or 9 read replicas and spending tens of thousands of dollars essentially. And then the moment they started using ReadySet, this was exactly the load on their backend primary database before ReadySet. After it, it's almost gone down to 0. And one of the quips that we heard from the DBA out there was, I slept through, the shopping event, the Black Friday event and the Cyber Monday event. Essentially because he knew that all of the queries were getting routed to ReadySet and they were getting sub-millisecond latencies for all the important queries. They are right now, caching just 22 queries or something like that, and that's it. Those are the bulk of their really heavy queries, and it's been a big sort of this thing for them. I just want to leave this off by saying we are hosting a happy hour. We would love to see everyone out there. We'd love to talk to you about ReadySet and in general about the databases. So please do come by.